Assalamualaikum guys, my name is Muhammad Jibril Mawanawi. Today I am going to be talking about chapter 2 in calculus 1, which is differentiation. Now, first of all, I would like to introduce my group mates, which is the first one being Khalis Firas, second one is Aizul Shah, and the third one is Adam Haikal. Now, for my part, I am going to briefly talk about what is differentiation and what are the different techniques and rules that we should follow in order to solve an equation in this topic. Now, let's us move on. For the first thing, what is actually differentiation? So differentiation is the process of finding the rate of change of a function. It gives the slope or gradient of a curve at a specific point. This means that whenever we use differentiation, it means that we need to determine the gradient of the graph, and moreover, this shows how one quantity changes with respect to another. Differentiation is written as dy or dx or f prime x, which is what we differentiate from fx, the function of x. Now, for the first technique that we are going to be talking about is the power rule. As you can see the formula below, power rule is essentially what we bring the power of the equation itself up front, we multiply that by the original equation, and we have to reduce the power itself by 1. To give a clear perspective, I have shown you guys an example below that we can look at together. Now, we can see that the example, the function is x to the power of 10. Now, how do we differentiate that? First of all, we have to bring the power up front and we multiply that by x, which is the original equation, and the power of 10 itself, we have to reduce it by 1. So, which gives us a clear answer. To differentiate the function x equals to x to the power of 10 is 10x to the power of 9. The second technique that we are going to be talking about is the product rule. Now, we only use the product rule whenever the question is in multiply. For example, before I go on to the example, let's first look at the formula itself. Now, the formula for a product rule is simple, which is f prime x or dy over dx, equals to u v prime plus vu prime. Now, to give a more clear perspective of what I just said in the formula, as we can see in the example shown below, we have an equation y equals to x squared multiplied by x plus 3. Now, y is essentially the function of x, and we can see that the tiny dot, that means we have to multiply it. So how do we actually differentiate this? Is by using the product rule. Now, let us say that x squared equals to u and v is x plus 3. Now, first we have to differentiate those u and v's, and after we differentiate that, we can then insert it into the formula itself. In the example shown given, u is x squared and u prime is 2x, which we already learned before. By applying the power rule, in order to differentiate x squared, we have to bring 2 to the front and multiply it by x, so we have 2x, and we always have to remember to reduce the power by 1. So 2 minus 1 equals to 1, which is x. Now, if you look at v is x plus 3. And when we differentiate it using the power rule, we were only left 1 because 3 doesn't have any coefficient. And we just insert it into the formula itself and we simplify the answer. Now, last but not least, the third technique that we're going to be learning today is quotient rule. Quotient rule just means that whenever the question is being divided, we have to apply this rule in order to differentiate the original function. Now, the clear differences between the product rule that we just learned before this, quotient rule is divided and product rule is whenever the question is multiplied. Now, the other difference that we can see is in product rule, we plus the two equations that we already differentiate. Now, in quotient rule, we minus it. As you can see in the formula, dy over dx is equals to vu prime minus uv prime over v squared. Now, always remember that whenever the question is given, u is always at the top and v is always at the bottom. In our case here, y is equals to x squared over x plus 1. Now, let's say u is x squared and v is x plus 1. So first we have to differentiate these two by using the power rule that we just learned before this. And after we already differentiate the two equations, we can then insert it into the formula that I just said previously. And after we apply it into the formula, we then have to simplify the answer, or not, the answer will be known as incomplete. Now, that is all from my part. I'm going to be handing you guys over to my group mates to give a in-depth explanation of these 3 techniques that I just stated before this. Take it away, Firas.
Thank you, Jibril, for your explanation for this topic. So, let's look at this question. Okay, for question A, we need to find dy over dx for y equal to 3x to the power of 2 sine 2x. So, let's look at the solution.
Okay, let's begin. For this equation, we need to use product rule because why? There are 2 types of function, this and this. First of all, you need to elaborate first. For this function, you need to elaborate u, and for another one is v. For product rule, we need to rewrite it again. U equation equal to 3x to the power of 2 and v equal to sine 2x. For this this and this, you need to differentiate first. For this, you can get 2 multiplied by 3x, and then you get 6x. And then for v, you need to change it to cos, and then you just copy this, and then you need to differentiate this like this, and you can get 2 cos 2x. For formula product rule is use dy over dx equal to uv plus vu, this prime and prime. You just use the cross multiplier. Then you just insert all this equation. For this, 3x power of 2 multiplied by v prime is v prime, 2 cos 2x. And then for this, you use sine 2x multiplied by u prime, 6x. Okay, I'm sorry, there is error. For the last answer, you can get 3x to the power of 2 multiplied by 2 cos 2x plus sine 2x multiplied by 6x. So you just solve this, and you can get 6x to the power of 2 cos 2x plus 6x sine 2x. As you can see, they are the same number, 6x and 6x to the power of 2 and 6x. You need to factorize it. 6x bracket x cos 2x plus sine 2x, and that will be the final answer.
Okay, for this question, it tells us to use chain rule to differentiate y equal to sine bracket x to the power of 3 minus 2x to the power of 2 and plus 1. So let's look at the solution.
Okay, for the next question is y equal to sine. Bracket x power of 3 minus 2 x power of 2 and plus 1. We can for this question, they ask me to do a chain rule. For the chain rule, there are 4 steps. For example, I will write y equal to x plus n bracket n. First of all, for the first step, you need to bring this power to front, and then copy this first, and second, you need to copy the function, and then you need to minus the power of n like this. Third step. Third step. And for the last step, you need to differentiate this equation. For the example, this. You just get x. Okay. So let's begin for the question. First of all, you need to change it first. Cos, and then you copy again x to the power of 3, and then minus 2 to the power of 2 to x to the power of 2 plus 1, and then you can see there are no the power. So you just differentiate this equation. You can get 3x to the power of 2 minus 4. I will do this. Okay. We bring this to the down. 3x to the power of 2, then minus by 4x and plus 0. How you get 0? Because there are no power. Okay, then you just bring this to the front because it's multiplied, right? And your final answer, you will get 3x to the power of 2 minus 4x cos x to the power of 3 minus 2x of 2 plus minus 2x of 2 plus 1. And that's will be your final answer.
Okay, that's all from me for the question 2. For the next question will be done by my friend, which is Aizul.
Okay, thank you Kalis for that wonderful explanation on question 2. Now let's go to question 3. So, given the question, given e to x plus 1 minus x to the power of 2 tan 2y plus ln xy equals 0, find dy dx using implicit differentiation.
Okay, so e to x plus 1, you know that the power is the exponent, so we can differentiate the inside, so we just rewrite this 1 plus 1 times, when we exponent this, 2x, we bring the power of 1 forward, so 2x times 2 times 1, so it is 2, and 1 we just cancel it out. And then we can bring the 2 forward, so 2a to x plus 1. Okay, so for the next one, which is ex to tan 2y. So we see that they have tan here, so we can actually use the product rule, which is dy over dx equal to uv must be u. So the u, which is minus x to the power of 2, v tan 2y. So the u prime, which is we bring minus 2x to the power of 1, and the v prime, which is, okay, so this is the long part. We know that in trigonometric identities, 1 plus tan theta equals sec 2 theta. So we can write it as d over dx tan 2y equal to sec the power of 2 to y, the power of dy over dx, and then we just bring out the 2y. After that, separated the 2 and the y at the back, so it becomes 2 dy over dx. And finally, we combine 2 sec the power of 2 to y, right, times dy over dx. So when we finally put together all of them using this formula, we get minus 2x to the power of 2 and 2y minus 2x to the power of 2 sec to the power of 2 to y dy over dx. So for the third part, we have ln xy. So we just differentiate ln xy, which is 1 over xy times d over dx xy. Separate them. power of x dy dx plus y. And I can separate this one, so it's easy. So 1 over y times dy over dx plus 1 over x. So I will rewrite this, so it's easy to understand. 1 over x plus 1 over y times dy over dx. So now that we have differentiate all of them, we just have to combine. So the combined one, d over dx, which is, I'm going to rewrite here all of them. 2 tan 2y plus 1 xy equals 0. So we just put all of them together, so 2e 2x plus 1 minus 2x tan 2y minus 2x power of 2 sec to the power of 2 2y dy over dx, okay, plus 1 over x plus 1 over y of dy over dx, and equal to 0. But we just isolate the dy over dx. So dy over dx, we just take this one and all of this. So we just write 1 over y minus 2x to the power of 2 sec to the power of 2 2y. So we just close the, and we move the rest of them onto the other side. So minus 2e x plus 1 plus 2 x tan 2y minus 1 over x. And lastly, we just bring all of this to the other side to isolate the dy dx. So dy dx equal minus 2e 2x plus 1 plus 2x tan 2y minus 1 over x over, I will write this one, 1 over y minus 2x power of 2 sec 2 y. To rewrite it in a cleaner way, we do d over y dx equal 2xy tan 2y minus 2y 2x plus 1 minus 1 divided by x minus 2x 3y sec 2 and 2y.
So that is all for question 3. Now I will be passing question 4 to Adam.
For the question 4, use linear approximation to estimate the value of square root 15.98 over 3 minus square root of 4 15.98. Correct to 3 decimal places. So let's look at the solution.
So I'm going to do question number 4. So let's say fs equal square root x over 3 minus square root of 4 x. And then we have to change the square root to power 1 over 2. So over 3 minus x by power of 1 over 4. And then move delta x equal x minus initial value 15.98 minus 16. So the answer is minus 0.02. And then substitute in this question. So this 16, square root 16 over 3 minus square root of 4, 16. And then 4 over 3 minus 2. So the answer is minus 2 over 3. Next, we have to differentiate. So we have 1 over 3 x power 1 over 2 minus x power 1 over 4. This we have to differentiate, and then we get 1 over 6 x power 1 over 2. We have to minus 1. So we get power 1 power minus 1 over 2 minus, and this we have to forward this the power. So 1 over 4 x, so we get power minus 3 over 4. So we have to move the powers because it is minus. We have to move to below. So we get 1 over 6 square root x minus 1 over 4 square root of 4 x power of 3. And then we have to substitute the, let's say f prime. So x is 16. 1 over 6 square root 16 minus 1 over 4 square root of 4 16 power of 3. And then we get 1 over 24 minus 1 over 32. So the answer is 1 over 96. Last but not least, we have to substitute the value in this formula. Initial value minus delta x equal f initial value plus, so f prime initial value delta x. So f in the bracket 15.98 equal 16 plus f prime 16 multiply negative 0.02. So how I get 15.98? So this is a delta x. So delta x is x. This x minus x initial value. So look at this, initial value minus initial value. So we have to cut this, and then we get negative x. So this we have to move this. So negative 2 over 3 plus 196 multiply negative 0.02. So that negative 2 over 3 plus minus 1 over 4800. So the answer is negative 0.9667. So this is the final answer.
So that's all from us. Thanks for watching.